Good afternoon, everyone. Our topic is about esters, and this presentation is prepared by Cueva Rick Joshua, Lawas Clarice Ann, Nunez Kian, and Tormes Joshua Aaron. In this discussion, we will be tackling the general properties of esters, some of its examples and uses in our daily lives, and in the last part, there will be a little additional information about esters. Now, let's start from the general properties of esters. But the first thing that we need to do is understand what ester is. So, ester is basically a chemical compound that is derived from an organic or inorganic acid in which at least hydroxyl group is replaced by an alkyl group. To put it in simple terms, esters are the group of chemical compounds which are formed by bonding of an alkyl group which a group of organic acids by losing water molecules. So the most common discussed ester is ethyl ethanoate. In this case, the hydrogen in the COOH group has been replaced by an ethyl group. The formula of ethyl ethanoate is located below. Then notice that the ester is named the opposite way around from the way the formula is written. The ethanoate bit comes from the ethanoic acid. The ethyl bit becomes more ethyl group and on the end. Then the esters can be made from carboxylic acids and alcohols. In general terms, the two combined together, losing a molecule of water in the process, considered a very simple ester such as ethyl ethanoate. The figure below shows its information from ethanoic acid and ethanol. So, in the figure, the diagram shows the relationship between the ethanoic acid and ethanol and ester. This is not intended to be a full equation. Water, of course, is also produced. So esters, to sum up everything, esters are also usually derived from carboxylic acids. It may also be obtained by reaction of acid anhydride or acid halides with alcohols or by the reactions of salts or carboxylic acids with alkyl halides. So esters feature a carbon to oxygen double bond that is also singly bonded to a second oxygen atom. Now, I give you Mr. Joshua Aaron Termes to discuss further the physical properties of esters.
Thank you for the introduction. Boiling points of ester. Small esters have boiling points which are similar to those of aldehydes and ketones with the same number of carbon atoms. They have a weak dipole-dipole interaction, therefore it has a weak intermolecular interaction, resulting in a low boiling point. What this means is that the forces of the bonds between each molecules are weak, which makes it easier to break apart. Now, Now, small esters do not form ester-ester hydrogen bonds, so their boiling points are significantly lower than those of an acid with the same number of carbon atoms, which is shown by the figure above. For those who didn't know, hydrogen bonding is a type of dipole-dipole interaction. In the case of H2O or water, there are partial charges on hydrogen and oxygen in water, so they attract each other from separate molecules. This attractive force makes them harder to separate and enter the gas phase. Now, the solubility in esters, though esters cannot hydrogen bond with each other, they can hydrogen bond with water molecules. One of the partially positive hydrogen atoms in a water molecule can be sufficiently attractive to one of the lone pairs on an oxygen atom in an ester, thus forming an hydrogen bond. As the length of hydrocarbon chain increases, it requires more energy to overcome the hydrogen bonds between molecules as the molecules are more tightly packed as the size of the and mass increases. What this means is that esters are fairly soluble in water, but solubility decreases with increasing chain length as shown below. Melting points. Melting points determine whether the substance is a fat if it is solid at room temperature or an oil if it is liquid at room temperature. whilst dispersion forces or IMF between the molecules allow more allow more stronger bond with each molecules. Thus, more energy is required to separate the chains, increasing the melting point. Unsaturated fats and oils have at least one carbon double bonds in at least one chain. Rotation about a carbon double bond is constrained, lacking a permanent kink into the chain because the kink or rigid bond hinders the tightly packing of the molecules. What this means is that as chain lengthens, it often tends to pack together tightly, but the double bond in between two carbons hinders the chain's ability to tightly pack to one another. And now I will give you the examples and uses of esters.
So I'm gonna be talking about the examples and uses of vectors. So the first example is the the first example is the octylacetate, where this ester is used as the basis for artificial flavors and in perfumery. It's also used as a solvent for nitrocellulose, waxes, oils, and to some resins. The second example is the ethyl acetate, where this ester is a widely used solvent, especially for paint, varnishes, lacquers, cleaning mixtures, and also in perfume. And the next example is the ethyl formate. So this ester industrially is used as a solvent. It is also used as a fungicide and larvicide in processed foods such as dried fruits and cereals. And the fourth example is the benzyl acetate. Just like the previous ethyl acetate, it is also a widely used solvent. It has artificial fragrance of the flower jasmine used in perfume and soap perfume, a flavoring agent and a solvent for cellulose, acetate, and nitrate, natural and resins, oils, lacquers, polishes, printing ink, and varnish removers. And the last example is ethyl butyrate. Just like the ethyl formate, it is also used industrially as a solvent, and it is also used as a herbicide and a fungicide in processed food. It has an artificial flavoring that resembles orange juice or pineapple in alcohol beverages as an ingredient of fragrance and a solvent or and plasticizer for cellulose. So that's all for the examples and uses. The next topic will be discussed by Kian Nunez for your information.
Thank you for that wonderful introduction, Mr. Cueva. And now, let us move on to the for your informations on esters. The term ester was introduced in the first half of the 19th century by German chemist Leopold Gmelin. Gmelin was a botanist, and esters were very common on plants. That is why he discovered esters. Esters can also do many reactions. It is very easy to change the either part of the molecular with any other similar one. It is also possible to reduce the ester to ketone or an alcohol, which can do many different reactions. So this means you can break down esters to create alcohol and a ketone. An ester is a carbonyl with a group on a carbon atom. The group can be written as COOR or carbon, oxygen, oxygen, and an R group. They can be made by reacting a carboxylic acid with an alcohol with some acid. Esters are any of a class of organic compounds that react with water to produce alcohol. anorganic or inorganic acids. This means that esters, if combined with water, can result in an alcohol. Our very favorite beverages that are wines, beers, and other alcoholic drinks. Many naturally occurring fats and essential oils are esters of fatty acids. Esters derived from carboxylic acids are the most common. These fats are mostly found on living things. One example is the stearic acid, an example of a saturated fatty acid. The second example is a linoleic acid, an example of an unsaturated fatty acid. Esters are very useful in so many ways. Common fats and oils are mixtures of various esters, such as stearin, present in candles, palmitin, present in soap, and in linolene, present in oils from seeds, formed from the alcohol glycerol and fatty acids. So these products are from esters. The candles to light our homes, soaps to clean our bodies, and the oils from seeds that we use for cooking. Quite useful. So, one way to create these products is saponification. Esters react with water, or also called as hydrolysis, under basic conditions to form an alcohol and an acid. When heated with a hydroxide certain esters, the composed yield soap and glycerin. The process is called saponification. So this means this chemical reaction is a result of saponification, the usual products that are very common in our bathrooms. When ethanol and acetic acid react, ethyl acetate, an ester, and water are formed. The reaction is called esterification, or more specifically, Fischer esterification. When carboxylic acid and alcohol combine, they will result in an acid. It will result in an ester and water. So our last part of FYI is methyl acetate formed by the reaction between methanol and acetic acid is a sweet smelling liquid used in making perfumes, extracts, and lacquers, just as Mr. Cuevas said. So this ends our discussion about esters. I hope and we hope that you learned something from our presentation. Have a good day and goodbye.